Okay, as always, the test that you'll get is very similar to this. I won't go over everything. I'll just go over the major topics here and make sure you can do this practice test before you take the actual test. All right, so let's see. Question number one says solve for x. We got a circle and it says assume that the lines which appear to be tangent are tangent. So we just simply need to remember that if lines are tangent to a circle and they come from let me do this in red, and they come from a common point. So if two lines are tangent coming from a common point, then that simply means that the two tangents are equal to each other. And since this tangent here on the left is 2x plus 2, and this one on the right here is x plus 10, we set them equal to each other. So 2x plus 2 is equal to x plus 10, and simply solve that equation for x. So we got x's on both sides, subtract x from 1x from both sides, so we get x plus 2 is equal to 10. Subtract 10 or 2 from each side, and we get x is equal to 8 for the first one. So all the ones that look like this, that is how they are done. So x is equal to 8. Okay. Let's see what else we have in store. So this is the same one. Notice we have this. I'm not going to do this one, but just notice that we have this bit of extraneous information here of 23.1, which is the radius, when in fact that's not anything that we're even going to use to solve this problem. Same thing, set 2x plus 6 equal to 3x minus 5, solve for x again. All right, so I gave you a bunch of those. So I'll give you 4 of those to solve. All right, so question number 5, a new topic. It says determine if line AB is tangent. So let's see, what theorem do we have that said if we have have a line that's tangent to a circle? We had the one that said that if a line or segment is tangent, so the point of tangency here is point A. So if you have something that's tangent, then at the point of tangency, if you connect that point of tangency to the radius or diameter, you must form a right angle, 90 degrees. Therefore, the triangle right here, if it is in fact tangent, will be a right triangle. If it's a right triangle, then a squared plus b squared will equal c squared. So this whole problem, the ones like this, simply boil down to if line AB is in fact tangent, then it should form a right triangle. We can confirm that with the Pythagorean theorem. So let's see, does 8 squared plus 6 squared equal 10 squared? So that'd be what, 64 plus 36, and that does in fact equal 100. 64 plus 36 does in fact equal 100, so therefore it is a right triangle, therefore it is tangent. All right, so here's another one done exactly the same. Notice we have a radius right here, so just be careful for this one. And I'm just going to point this out. This is the one you probably have questions on. If you're dealing with a radius, in the previous question right here, notice on our right triangle here, let me do this in red. On our right triangle on the previous one, why are you not drawing? On our previous triangle, this side of the triangle right here was just the radius, but notice on our next problem, it's the same technique, but on the next problem, the side of the triangle that's listed with the radius, it would be 2 radii. So if let's see, if from here, from point A to the center is we're labeled as 8, then from here to the other side would also be 8. In other words, that side of the triangle is not 8, but it would be 8 plus 8 is 16. So confirm whether or not 12 squared plus 16 squared is equal to 20 squared. Now you're like, how do I know that this 20 applies for the whole thing? Because notice this 20 is right next to that blue line right there. So it's saying that the entire thing is 20. And then lastly, I'll just go ahead and say this. If they were, in fact, if 8 was right here at the center, like right next to this little dot right here, then they are, in fact, telling you that the diameter is 8. But since the 8 is not there, it's off to the side there. That's how I know it's a radius and not a diameter. So that one can be a little bit tricky simply because the way the question is written. But hopefully that made sense. This is still the same thing, Pythagorean theorem to determine whether or not AB is tangent. Same thing here, nothing tricky here. And once again, that 16.1 is all the way from the center of the circle to B. Another one here, notice now they're giving us, hey, 6 is in the center, so that's the entire distance right there. Okay, what else we got? Ooh, no problem. What do we got here? So it says, name the arc made by the given angle. Now, arcs, remember, come in 3 different flavors: minor arc, major arc, and semicircles. And so this one, it specifically tells us right here, it says, name the major arc for angle 2. Or here's angle 2, and angle 2 clearly makes a minor arc, U to V, right? Can you see that? It makes the minor arc UV, but that's not what it wants. It wants the major arc that's associated with angle 2. So the major arc will be what's left of the circle. So from U all the way back around here to V would be the major arc that's associated with angle 2. All right, so how do you write that? Well, remember, I need 3 letters for a major arc. You can start with U or V. If I start with U, the last letter has to be V, and I need a point in between. You can pick T or W. I'll pick T, and then put the major arc symbol over the top, and you're done. If you check what they put as an answer, just take it with a grain of salt. So they just said U, instead of choosing T, they chose W. Either one is fine. So there's lots of possibilities here. If they started with V, it could have been VWU or VTU. Hopefully that made sense. All right, so that's it for the major. There's another one for a major. Let's do a minor. They can ask this question the same way, except ask you to name the arc for the given angle. Notice this one doesn't say major arc, it just says angle 1. So this is how I know they want a minor arc. So here's angle 1 right here, and the arc it makes is HI. So it's not going to say name the minor arc, it's just simply not going to say name the major arc. So I'll say that one more time. So if they want us to give the major arc, like in the previous questions, I'll go back to that. On the previous questions, notice it says name the major arc for angle 2, whereas this one just says name the arc for angle 1. So without the word major, then they want the minor. And remember, it could be HI or IH. All right, reversing around, now they're going to give you the arc, and they want you to name the angle. So let's see. They gave me 3 letters, so this is going to be a major arc. So I need to go from C to F to D. So I make sure you go in the right direction, from C to F to D. So if I go from C to F in this direction, notice I just went by D, and I need D to be the last letter. So I went in the wrong direction. So I want to go in the other direction, from C to F, and then finally to D. And notice what's left over is this angle 2. And so angle 2, which is technically names 2 things. It names minor arc CD, and it names major arc CFD. So this answer is angle 2. You just need to do a couple of these to wrap your head around them. All right, so minor arc ED, this one's pretty straightforward. Minor arc ED, well, that would be angle 2. All right, so here's a bunch more for practice. Moving on to the next topic. All right, so now instead of just naming things, we'll be finding actual angular measurements of either angles or arc. So it says find the measure of the arc or central angle as indicated. Remember, the relationship between arc and central angle is they have the same values. So these are all the ones that require sometimes a couple steps to figure them out. All right, so let's see what this one is asking us. So it says the measure of JK. So I need to, for a final answer, I need to know what that arc measurement is right there. And remember, that's also this angle measurement right here, it's central angle. So it can be done one of 2 ways. If I'm lucky, right, then look, we got vertical angles right here. Sorry, right here. And right across from it, would be an angle. Oh, why does it keep doing that? If we're lucky, we'll have that angle measurement right there, but we're not lucky and they didn't give us that. So a different idea here. So let's see what we got. If that method doesn't work, I would always look to see for what do you have for diameters. And notice I've got a couple diameters. I got this diameter and I got this diameter. I am going to go with, well, if I mean literally, I could go with either one. I'm going to go with this one. And notice, why am I going with this one? Because look, I've got angle 60 for right there. Central angles are equal to arc measurement, so that would be 42 for this one right here. I'm getting that from the central angle. And so I'm only missing the blue part, JK, which is what I want. And we know that for a semicircle, diameters, remember, breaks up the two halves of the circle. We have 180 degrees. So this would be 60. Let's see, 60 plus 42 would be 102. And then I simply need to subtract that from 180. I'm not going to write that down. That was pretty straightforward. So this one would be 78, or I can put it right here, equals 78 degrees. Oh, it's going to be a long class here because my thing isn't, I think I'm just pressing the mouse button too hard. I think that's what's going on here. All right, so 78 degrees is the answer. Just confirm. Yep, 78 degrees. All right. These come in lots of different forms and fashions. Some of them are a bit more challenging than others. So once again, the key is always remember to look for diameter if they have diameters, or understand that there's 360 degrees in a circle. I'm trying to find one. Here's one without a diameter. So we're trying to find the measure of angle JLI. So let's see. Let's highlight that one. J to bothering me. J to L to I. So that's the angle. Notice that this arc is not labeled, and I have no diameters, none whatsoever. But notice, I do in fact have this arc, which is 85, this arc, which is 60, this arc, well, the central angle is 70, so that's 70, and this arc right here is 70. So if I added up all of those angles, let's see this, so that would be 85 plus 60 plus 70 plus another 70. That gives me 285, and if I subtract that from 360, I get 75 degrees. So that's going to equal 75 degrees. So once again, we're looking for diameters, or in worst case, like here, 360 degrees in a circle. And then I would always, if possible, if there are central angles or vertical angles, use the fact that you have vertical angles here. We don't have any of that. So we had to go with the 361. All right, let's see if anyone looks fanciful, looks challenging. These look all pretty straightforward. Here's another one, no diameters right here. But notice they gave us all angles. That's just like the previous one. Just add up all those arcs and subtract from 360. Here's one that where we got a diameter. Oh, we'll go ahead and do this one. So let's see. What do they want us to find? They want us to find EAF. So I'm going to trace E to A to F. So they want us to find the measurement of that arc or this central angle right here. Either one, because remember, central angles equal the arc. And notice I don't have all the arcs around it, but I do have a diameter. So I can draw this diameter a couple different ways. If I draw it this way right here, then I can find out this just by subtracting 130 from 180, which would leave this one as 50 degrees, and just keep going around the circle. So notice that one's 50, this one is 55. So let's see, 50 and 55 is 105. Subtract that from 180, and that would give us that last arc right there, which is 75 degrees. And now I have all the arcs or all the angles. I can add them all up and subtract it from 360. Or, remember I said there's other ways of doing it. Here's an easier way. Notice that this angle, or these two lines right here, form vertical angles to the one that we need. Therefore, I know this one is 50 degrees. So, if you didn't notice that and you went the route of add them all up and subtract from 360, you'd still get the same answer of 50 degrees. But if you were really looking careful at the picture, you could see that you had vertical angles right there. All right, so hopefully that all made sense for that one. That one's kind of interesting. And I guess, once again, I'll just reiterate the three main things you're looking for are diameters, you're looking for vertical angles, or you're looking for all the angles add up to 360 in a circle. All right, so new type of question. So let's see, what do they want us to do here? Find the length of the indicated segment. All right, so these come in two flavors. The two flavors kind of look like this. They're either going to have us find a part of a radius. Hey, look, from the center out to here is a radius. It's a radius, and so x is part of the radius. Notice the other part is 7.7. So what's the radius? Well, let's see. I have that right here at the center that this is 24. So the radius would be 12 on each side of this. So I don't need to do it twice. So if the radius is 12, and I'm going to go back to this part right here, well, I got 7.7 as part of it. So I simply need to do 12 minus 7.7 to figure out that x value. And that x value is, if this would draw for me, so x is 12 minus 7.7 is 4.3. So 4.3. I said this comes in a couple different flavors. So let's see another flavor of this one. Oops. Yeah, that worked. All right. This one, well, let's see. The second flavor is right here. Notice that x is a radius. And then is the radius actually listed somewhere else? Well, no, but let's see, from here to here was 5.4 plus 3.7. So that'd be what, 9.1? All right, so we'll just basically call this first flavor. First flavor is they actually have you solve something about the radius, maybe even the diameter. Second flavor is, this is still a radius problem. Second flavor, I'm trying to see where x is. Ooh, this is a good one right here. Notice this one right here, we're still trying to find part of a radius, right? And I know the radius is 18.4, and I know this value is x, but this 14.5 is not this value. That 14.5 is this value. Well, remember, if you have a circle and you have a chord and you have a radius or diameter that goes through the chord and makes a right angle, then it breaks that chord up into two equal parts. So if it breaks it up into two equal parts, then that means that this side is also 14.5. And how is that useful? Because if we ignore everything, we got a right triangle there, and therefore I can use Pythagorean theorem. So that would be what? 18, the hypotenuse is 18.4. So 18.4 squared, that's, how do I know that's the hypotenuse? Remember, that's the side opposite the right angle. So 18.4 squared is equal to the 2 legs squared. One of them is 14.5 squared. Remember, we got a calculator, so don't panic with these ugly numbers, plus x squared. So square 18.4, square that. And then from that, I'm going to subtract 14.5 times 14.5. And then lastly, I need to take the square root of that. So this is going to be a really ugly number. You're going to have to do some rounding. Notice it does say round to the nearest tenth. And so the answer is 11.3 after you take the square root of both of that side right there. All right, I'm skipping the work there, but we've done enough Pythagorean theorem. I know I'm confident you know what you're doing there for that. Let's see what else we got. I was looking for a specific one, and I'm not seeing it. These are all radius ones. I thought there was a really easy one. There's no Pythagorean theorem, that previous one. This is also, yeah, this is also Pythagorean theorem 1. All right, just be on the lookout for the test that if they, in fact, they do ever give you, I didn't give you an example here, but if they ever give you this as 18.3 and the x is right here, well, then there's no work involved. It's 18.3. Remember, a radius, cutting a chord and making a right angle, then that cuts the chord in half. Okay, next topic. This is basically going to be inscribed angles right here. So let's see what we got here. Well, here's the question mark right here. So if we follow that inscribed angle, that makes our GF, which is labeled, but 33 degrees is labeled. And if we follow, this is going to, I'm going to have to do it in a different color, otherwise it's going to get too weird looking. So if we follow that one out, And remember, the arc is double the angle, or the angle is half the arc. That would make that 66 degrees. Not what we're looking for, because we're looking for this red arc right here. Well, notice, I need a different color. In green, notice once again, we have a diameter right here. And I know that this is 66. So that means that this arc right here would be what? So it'd be 180 minus 66. 180 minus 66. That's 114. So the arc is 114 degrees. And if you don't think this through, you're going to write that as the answer. Remember, we need, for the angle, we need half of that. So we need to divide that answer by 2, and we get 57. So question mark equals 57 degrees. I tried to draw a 5, and I made a 7. There we go. 57 degrees. And that is the answer to that one. I'm just checking. Yep. All right. What else we got? Okay, that's a pretty darn complicated one right there. A couple steps to get to the answer. This one looks less complicated, so let's see how we can do this one. We got an inscribed angle. So we know the arc is double that angle. From C to B is 80 degrees. Ooh, we can do this one pretty simple. Question mark is the arc. Notice I got a diameter right here. So the only thing left there would be 100 degrees, because remember, a diameter has 100 degrees. I don't want to do them all, because I want to leave a couple of them for you to think through. All right, we'll do this one. Call it quits after this one. So let's see what we got here. So we got an inscribed angle there with a question mark. So basically, I need to find, let's see, I need to find this angle right here, or this arc right here, and then take half of it. Oh, look, I got another diameter. So let's see, that would be 180 minus 106, and that would be 74 degrees. So this part is 74 degrees, and remember, the angle is half of the arc. So half of 74 degrees would be 37 degrees. So question mark is equal to 37 degrees. All right, that was kind of fun. Check the answer. Yep, 37 degrees. What else we got? Ooh, quadrilaterals. Remember, if you have an inscribed quadrilateral, opposite angles are supplementary. So where's the question mark? Well, the question mark is right here. I did it again. Question mark is right here. So if we look at what inscribed angle that makes the angle from here all the way to there, which is not labeled. Let's see, what other information do we have here? Well, we got this 83. And the 83 would go from here. Oh, this one's going to be messy. From here to here. Did that help us at all? No, if we double that, so I'm going to have to draw this in red here. So if we double 83, we would get that arc. Is that what I want to do here? I guess we've got to do that. Oh yeah, because then we'll just subtract everything from 360. So we can figure out TG after we figure this out. So let's see. From because the legs are there, so double 83. So if I double 83, 83 times 2 is 166. And if I subtract what, 76 from 166, I get 90 degrees. So this angle right here, I better erase part of that. Where's my eraser? Right here. So I'm going to erase that and redraw that arc that I just labeled. So from T to G is 90 degrees. And now I have all the angles with the exception of E to F. So let's see, I'm going to add 90 and then 76 and then 94 and then subtract that from 360 and I get 100 degrees. So this part right here is 100 degrees. Why did I go through all of that trouble? Because I'm going to erase everything except for I need the eraser. So I need the eraser, not spotlight. Okay. Talking to myself here. There we go. All right. So to find the question mark here, remember that would be from here to here as an arc and then take half. So that would be from here to here. So 100 plus 76 is 176. Divide that by 2 and we get 88 degrees. That was a long an arduous path there to the answer of 88 degrees, but that's what you can expect on that particular one. Okay. Any other big one? Okay, that's still an inscribed angle. That's inscribed. Ooh, here we go. All right, so we got an external angle here to the triangle, and we know that the formula states that I take the two arcs, the farthest one, this is the one that you're going to forget. Is it the one I add or subtract? This is the one you subtract. So from the farthest one, we subtract the nearest one, and then we divide that answer by 2, and it gives us this. Oh, it already gives us that angle. So let's see, 45 would be equal to the two arcs subtracted, farthest minus nearest. So 165 minus x would be the question mark, all divided by 2, and that's supposed to equal 45. So to solve that algebraically, multiply both sides by 2. So we get 90 is equal to 165 minus x. You will get a negative here on both sides after we subtract. Let's see, from 90, we subtract 165. You're going to get a negative, perfectly fine. So you get negative 75 because that's going to equal negative x. Notice that negative there. So therefore, x is 75 degrees. So x is 75 degrees, final answer. All right, another inscribed angle, farthest minus nearest. Ooh, there we go. Now we got Spider-Man. So remember on Spider-Man, we're trying to find, where's the question mark? Oh, it's right here. This is the same thing. We're just going to add these two. So remember, we're adding the arc that's across from it, not up and down, but across from it. So let's see, the angle is x here for the question mark, is equal to the two arcs added together. So that would be 55 plus 155 and then divided by 2. So 55 plus 55 is 110. Add another 100 and we get 210, but I got to divide that by 2, so we get 110 degrees. So x is equal to 110 degrees. Yay for us. 110 degrees. 105, where's my mistake? Thought we got 220. Did we get 210? Oh, we got 210. That's the mistake. So don't be like me, try to do all the math in your head. Use your calculator. And don't make a silly mistake. Okay. Inscribed or external angle, Spider-Man. Oh, okay. The last thing we do, remember the last section dealt with either Spider-Man or Ninja, and it dealt with segment lengths. And so remember the pattern for this one is, let's see, it's the whole thing times the thing on the outside. So the whole thing times the thing on the outside is equal to the whole thing times the thing on the outside. Remember, when x is on the outside, we got quadratic. All right, so let's see. The whole thing, I'll do the one on there on the right there. So 8 plus 6 is 14. So 14 times the thing on the outside, which is 8. And that's going to be equal to the whole thing on the other side. Yes, you got to do parentheses. 7 plus x will be the whole thing times the thing on the outside, which is 7. So let's see. 14 times 8 is 112. Distribute the 7, so that'd be 49 plus 7x. Subtract 49 from both sides. Let's see, 112 minus 40, that's 63. And yes, a math teacher wrote this question because it's nicely divisible. So x is equal to 9. There we go. X is equal to 9. All right, those are fun. And then for the last one, we have this shape right here, and this is your, oh wait, did we just do that one? No, we didn't. The last shape is the Spider-Man one. So Spider-Man one is the pretty one that's pretty straightforward. So this times this is equal to, let's see, on the other side, it would be this times this. All right, so let's see. 12 times 5, that's 60. And that is equal to 6 times x. Hey, we can do that one in our head. If 60 is equal to 6x, then x is equal to 10. And there we go. That will be the test. And the rest of them, I'm just checking to make sure nothing's weird. Oh, remember the one with the tangent right here. So remember, whole thing times the thing on the outside, and on the other side, it's that thing squared. So let's see, 4 plus x times 4 is equal to 6 squared, or 36. Solve that one. You run into any issues doing this? Let's see. Did I give you? I gave you no quadratics here because I gave you none where x is on the outside. So we'll keep that one for an algebra 2 problem for next year. All right, so that is your test. Make sure you can do all of these and be confident before you take the test. The test will be very similar to this one. If you have any questions, make sure you send them. If not, good luck. I don't know if I'm doing this a day ahead. I can't remember where you stopped last week as you see this. But wherever you are, just remember, don't take the test until you're ready. You can master all of these. All right, have a great day, and I will see you in the next class period.